All right, welcome to the stream. Welcome to this webinar. Thank you for joining, and settle down, grab a coffee, and feel free to mention where you guys are from. I would love to know more about you because I see more than 200 people signed up, but it's good to know where are you signing up from, where are you watching up from. It's 12 o'clock in the morning in Germany. I'm streaming from Germany. So good to know where are you guys seeing from. So in today's live webinar, in today's live stream, we're going to see how we can automate the process of sealing and labeling of the filled cans. All right. And this filled cans we did in the last webinar. We talked about how we can fill the cans. Okay. And now in this webinar, we're going to talk about how to seal the can and how to put a label on that. Okay. If you haven't seen my last webinar, I highly recommend you to check it out on LinkedIn, or you can also go to my website. There I'm uploading all this webinar. So basically this whole series of webinars, I think this is the 5th webinar if I'm not wrong, is uploaded in a course. And this course is called PLC exercise using Simumatik and CODESYS. So if you want to learn more about this course, you can check here. This course is for free. So you can just go to our website, codeandcompile.com, and go to courses. And if you drag down, you will see several free courses. One of them, which I'm working on right now, is this one, PLC exercise using Simumatik and CODESYS. And if you go inside, you will find in the curriculum, somewhere here, all the webinars, all the live stream, 4th, 2nd, 3rd, and this is the 4th one. So this is the 4th live stream. You will find after this live stream, I will upload this webinar here, and you can access that, okay? So don't worry if this is the first time you're watching me, all the old webinars are here. And I recommend you to start from scratch if you are new to Simumatik or new to CODESYS. All right, so good to see you guys. Mahesh, Jayesh from India, welcome, welcome. So what are we going to do today? So first we're going to see what is the end result, okay? What you're going to see in the end. So I'll skip to the next slide. So if you haven't seen that before, this was the last webinar where we were just filling the cans. So you can see that here, I am just filling the cans. Okay, so now I have extended this system with sealing and labeling. And that I can show you over here. So if I open my workspace, this is up and running. So it's actually, my system is fully loaded. I have a lot of applications running here right now. So let's see here, I can maybe restart it one more time. So I will start fresh, reset. And so I'm basically using CODESYS as a platform to write the code, and Simumatik as a digital twin platform to show you the emulation. So there was some error here. It's okay. Let's start now. So here we can see now we have one unit for sealing the can. So we are putting a seal on the can and one unit for labeling the can. So you can see what is happening right now. If I pressed start, you will see a can is coming, and this is for filling, and that's the sensor which tells you if the can is full or not. Okay, this we have seen in the last webinar. All right, and the next one is here the unit for sealing. So next step is there is a sensor here. It will detect the can, and these jaws will close, and jaws also have a sensor inside, which I will show you shortly. And then it will come down, make it rotate, turn, and it will seal it. And once it's sealed, it will be removed from this unit, goes to the next unit, and here you will see there's another unit which will pick this workpiece up, you will see shortly. And there are two wraps here. One is goulash, one is bean, and one is goulash. So it will wrap the product, bring it down, and then it will go further. So very simple process. It's not so complicated, but several steps are involved. Okay, we are going to see the steps shortly. But first, I just wanted to show you what I have already programmed, and I can show you how I program that. You can also have a copy of this program, and you can also use the system right away. You know, we have a Simumatik free platform, free account service in Simumatik. One is paid, one is free. So in the free service, you can access the system. Okay, you can just load the system, put your CODESYS OPCO address, and you can connect the code that I can give you, and then you can see how the system is running. And you can also change the code, change the way you want to program it. So everything you can start without paying anything. Although there are other benefits when you have a paid license, which I will tell you later in the end. So the step is just filling, putting a seal, and then putting a label. So I'm just putting my eye on the comments as well. So people are joining in. Rohit, hello Rohit, you're from India. I'm from India as well. I have another guy with Revel. Hi dude, I'm from India working in German automation engineer in Saudi. Welcome, welcome. Another guy, Dhruv Patel, just joined in from Canada. So multicultural people here. So yeah, I'm coming back to that. So we have 3 steps: filling, sealing, and labeling. All right. Now, I've told you about the course as well. I've shown you what we did in the last video. So let's see how this whole process is working. So you can understand that this unit has some IOs, right? You give some signal from the PLC, this unit will behave based on the signal. So all the signal control is done on CODESYS. So here you can see that that's my program. And if I open up this, here I have my main program, and this program is a little bit different from the last program. In a way, lastly, what we did, let me just shorten this screen. I hope this is fine. And maybe I will move to the next slide. All right, so in the last webinar, what we were doing, we were just making a basic code of filling. And this filling code we created in the main OB, like in one program, right? But now I have split the code. So I have made 3 function blocks for filling, for sealing, and for labeling. And I'm just calling this function block from my main block. This is how you can generally define in some other words, you can call it as a subroutine that you call the subroutine. So I have 3 function blocks that I'm calling in the main block for different applications. So you can see this is my main program. And if you recall from the last webinar, we are reading the inputs from our global variable. And then there's a conveyor control, very simple, start, stop, and main step 1 or 0. And there is a step for counting process cans. So we are counting the cans. Processed cans means the cans which are coming inside this workflow. These are the processed cans. So this first sensor is going to tell us the processed cans. So you can see that now it's 5. So it's like I'm reading the falling edge of this sensor to count the process cans. And then I have a filling function block. All right, and this filling function block is created over here. So the filling process, which you have seen in the last webinar, is now in a function block. And this is executed here. It's the same code, right? So more people joining in. Abdul Majid from Italy, Bala from India, Juzair from Kenya, Hamid from Iran. Welcome, guys. Welcome. Nice to have you here. Keep popping your questions if you have any regarding the webinar. I'll be happy to answer in between. So filling steps. So we have steps from 0, 1, 2, 3, 4. So we have 5 steps starting from 0, right? And these 5 steps we have done in the last webinar. So we are just filling the cans. After that, you have sealing, okay? So once you fill the cans, you have to seal the cans. So seal the cans, you can also see over here. We have a sealing function block. And in the sealing function block, you can see several steps. So this is something new in today's webinar. So what is happening in the beginning? I will pause the simulation. The first step is it's waiting for the can, all right? I'm not going to dig inside the code of every Boolean variable because this will take hours. So I will give you the code. You can read it later on. So I'm just talking about the steps of operation. First step is waiting for the can. So we have the sensor, which is waiting for the can. So when the sensor is true, it means can is there. So when the can is there, we grab it. We grab the can means we close this hooks. So we grab the can because we need to make sure can is at exact position, okay? Because we have to seal it. So we grab the can and then we lower the arm. So the arm will come down. Now you will see shortly, arm will come down and then we rotate it. We start sealing it. So once sealing is done, we lift the arm and then we reset the variable. So let's start it now. So now you will see it will first stop the conveyor, grab the can, arm will come down, make a rotation to seal, arm will go up, and this grabbing will be released and the can will go. One more thing, this unit is giving me a signal if lid has been placed. So you will notice here, there's a feedback coming, lid placed. Right now it's false, it will be true when the lid is placed. So we are having a feedback. So this is just to check if the lid is placed or not. Because if you see here is a counter 94, and this counter will decrement every time when the lid is placed. If this is 0, the lid will not be placed because there's no lid available. And then this will be false and your step will not execute. So let me go back to comments again. So one guy is from Nigeria. Hello, nice to see you again. All right, coming back. So this is how the sealing is done. So I'm going to show you as well how in Simumatik the sealing process is executing. What is actually happening inside? I'm going to show you shortly. There is also a catch. We are writing the data to the CAN. So the CAN has an RFID where we write each step. This is just to monitor the production, where your production is going, where the CAN is going. Does it has liquid? How much liquid it is? Does it has a lid? Does it has a label? We are going to check that in between. All right. Now let's go to the next step. Next step was labeling. So if you see that here, what happens in labeling, quite similar to sealing. First the CAN comes, sensor gets true, and when the sensor is true, it will grab the CAN. And once it grabs the CAN, it will pick the CAN, goes up, and then it will label it, and then it will come down and release the CAN. So let's see that one more time. Step number one is waiting for the CAN. So right now there's another sensor here, this one. This is waiting for the CAN. When the CAN is there, it will close the hooks. Close the hooks. Hooks also has some sensors. When the hooks are closed, we get a feedback from the sensors. We bring this gripper down. We lower the arm, turn on the vacuum, and then we release the hooks. Because when the hooks are making it in one position, we release the hook, it takes it up. Now you will see that. Waiting for the CAN, CAN is there, close the hooks, bring this arm down, and there's a vacuum here. It will grab the CAN, open the hooks, bring the CAN up, and you will notice here we have two labels, goulash and bean curry. So based on what did we fill in the step one, we are labeling it in step three. Step 3 means in the sealing and the labeling. So we are having such kind of signal passing within the PLC, and we're going to see that how we can further optimize that if we put a sensor here instead of passing the signal internally. And here you can see that we have some roles which also has some value, because this roles will also get empty at one moment, and we have to refill the roles. So these green buttons that you see here, it's to refill it. So right now you can see that this is some level. I can show you the level we can also read here. So if I go to my global variables, you can see label goulash and label bean. These are the levels, okay? So this will at some point goes to 0. So now you can see that when we are doing the labeling, one of this value will reduce based on which label is being used. So let's see that shortly. So we are having some feedback from our units. There you go. Now this was a green label that was label bean. This has been reduced, and it will even reduce when it's being used, right? And if I want to refill the labels, I can just click on this green button. Now you can see that this is filled and this as well. So I have this user interaction in Simumatik to refill the labels to avoid my production to be stopped. And here as well, there are a number of seal here, 91, and I can press it as well and make it 100 again. So feel free to play around with such kind of user interactions. So this was the sealing and this was the labeling. Sorry if I'm talking too fast. Sometimes I don't realize I'm talking too fast. So feel free to ask questions if you have in between. So yeah, this looks very simple, but if you are new to PLC programming, this could be a little bit complicated based on how you have to read the signals, if you're making everything in one block, or if you're making function blocks or functions. And now I'm going to talk a little bit about how the process has been flowing here. This is the most interesting part, because it looks really nice that the CAN is coming, you're putting the liquid inside, or goulash or beans curry soup, which you can visually see here. But what exactly is happening inside? So you can see that here. It's being filled, but is it really being filled, or is it some kind of a trick that we have used? I'm going to show you shortly. And then again here, how we are putting a lid, how we are sealing it, what is actually happening. So I'm going to show you, let's see that here. Now you can see that. There you go. The lid is there, and then it goes up. And then here we have the label. So I'm going to talk about how in the back end we have executed that. Because from the PLC, you're just giving Boolean signal on and off, right? But in real, there is some visualization elements which are being changed or optimized. So how this is happening, I'm going to show you now. So in this case, we did a bit smart way to do that is you take the product. Let me see if I can open the product. Oh, the product is gone. Let's take next product. Product 12, let's open that. So when I open the product page, you can see everything you can customize, even the products. So in the products, I have an asset. So this is asset means where you upload your 3D files, all right? So here you can see a lot of GLB files. So if you're from mechanical background, if you're doing some 3D designing, GLB is a format for CAD. So if I open this CAD format bean label, so you can see that this is my bean label. So this is just the label, right? Just the cover, which we label in the end. And then we have bean soup. This is the soup, how the soup looks like. So this is how the soup looks like. So basically, we just have one circle, which we are moving up and down, right? A circle in 3D, like one slice of the soup, right? Similarly, you have goulash. So here is a goulash, how goulash looks like. So basically, what we are doing is we are just moving the goulash slice up and down based on how much you want to fill or reduce. And if you can imagine, now we have just bean curry and goulash. You can also have a 3D file of cola or water or I don't know, juice or Fanta, whatever you want to fill, or oil. So the filling part is you just need to have a one slice, and that we can move up and down to show it's being filled. And this is being programmed in the editor where we have the behavior of the scan. So in the scan, we have some behavior. I will not go in detail about that, but the trick of putting the liquid and showing the filling and everything is just in the product. We have these elements which we are hiding and we are showing. And so right now here, you can see that now the cover is being shown in the can. Okay. When the can arrives, everything is hidden. The covers are hidden, the slices are hidden, the lid is hidden. Everything is in the object. And when it comes to particular station, we just activate to view it. So that's how we are showing how the can is being filled, how the lid is being placed, and how it has been labeled. Okay. And all these things, if you really want to learn how to make a digital twin of your process, you can do that in Simumatik, because this is what we are doing. Our developers are creating these systems. And for that, you need to have a license. So that's where the license part comes. If you're using Simumatik for free, you can just access it. You can just give the Boolean signal, move the units, and things will work as you want. But if you want to create something, if you want to create a system or create a component based on what you want, or for your process, for your industrial process or education process, or your could be MTech thesis, master thesis, bachelor thesis, if you want to create something, then you need a license. So this was about how the object is flowing. Another interesting part I want to show you about the object is, if I click on the object, you can see we have something called collision data. So if I pause it here, I don't know if you can see this collision data because, oh yeah, you can see it because my camera is also there. But I can maybe minimize it or reduce the size. Okay, there it's much better. So you can see there is a collision data. This collision data means the actual status of my object. So let's go and hit play. And now you will see that as soon as it is being filled, collision data will be updated. You can see it is in JSON format. It's a JSON string. And you can see that how level is being increased. Now let me pause that here again. You will see that the content is a bean soup because bean soup has been filled. And this is what we are writing on the object. And this you can imagine when you have RFID tags on your products, you write the information, what has been done in the last step. And if you want to learn more about RFID, by the way, I have a course on Siemens PLC Advanced where I talk about how you can use RFID to read and write data and how you can track the data. One example here is we are writing this data on this object. You don't see physically RFID on the can, although you can create it. You can just upload 3D file of RFID, put it on the can. You can do that as well, but this is just to show you. Collision data means what data is being written on this can. Okay, so it has a bean soup because bean soup was filled. Content level this is the content level. This is actually, I think, in meters, and this is the level of the soup. And now if it goes further, you will see here what will be written here. It will be written if the lid is there or not. So now you will see that it comes down, it will place the lid. As soon as it places the lid, you can see that lid is true. So we have written another data after the second unit that the lid is true, okay? Because we have to put the data, what has happened in the last step. And then you move further, and what is happening here? Here you will have the labeling. So we'll have another key label and the name of the label. So you will see that shortly. Once the labeling is done, here you will get the data. So every time the product is going through several steps, it is having the data. Now you can see that it shows label and bean soup. Okay, so you have a bean soup inside. So this is what was filled before. And lid is there and the label is there. Now let's check for the next part. I will hit play again. In the next product, I will have product here because last product is gone. This is product 16 and it's okay. collision data, right now none. Now we are filling, it was the bean last time, now it's goulash. Same the level. So you can later on also do some validations. What was filled is in my can, because once the lid is there, you don't know what is inside. It could be bean, it could be goulash, it could be anything else. But once you're writing the data inside, when it is being filled, you can later on verify that. That's the idea of using the collision data or RFID tag in different words. And here you can see that now it's goulash, and here, because it's goulash, it will have a red cover or red label, and it will show us another tag here. And this writing of this information, that is goulash, it's done inside the unit, okay? So I'm going to show you shortly how the unit has been programmed, okay? So let me just stop the emulation. So here, this unit you have seen already in the first webinar. This is the sealing unit, okay? If you see, when I click on this unit, I have collision data that it is being read, and number of lids that it possesses in the beginning. So you can change this number if you want to play around, 10 lids, 5 lids, 20 lids, this number you can change. So let me go back to comments, just coming back to you. So what Retrieval said, I need a course only for WinCC, can I make, okay, I will answer that later on, okay. If you have any question regarding this webinar, I will answer that right away. Other questions I will answer in the end. All right, so this was lid sealer. So let's go inside and see what is inside the lid sealer. So here you can see I also have asset. This is the 3D data, how lid sealer looks like. I can open it, I can show you. This is the arm of lid sealer, and then we have the base of lid sealer, and then we have the upper body. This is the rotary of the lid sealer. So you can see that we have different parts. So here you can also imagine if you're trying to make a component that belongs to your process, you can also upload 3D CAD data here, and then you can define its behavior in the editor. And if you want to learn more about how you can create your own component, there is a course on Simumatik's Academy where you will learn how to create these components. If you want to watch that, it's actually, you can search academy.simumatik.com. That's the academy I'm taking care. In Simumatik, I'm working as a content creator and community manager. And there, if you go to the courses, you will see there are several courses that I've created, and these all are available for free. So you will learn how to build the system, how to connect the system with PLCs or robots, how to build your lab, and this is the component builder, where you will learn how to build your components. So in the components, you can build decorative components, which could be just some logos, some cups, and just warning signs, or you can build components without physics, like these buttons and switches, or components with physics, like the one which we are working, these mechatronic units, some sensors, some robots, smart components, visualizing components. So all the components, how to create from scratch, you can learn in these courses. Coming back. So here, this component, if I go to the behavior now, in the behavior, you will see some things are happening. I will not tell you in detail, but here we are defining how this lid has to react based on the signals coming from the PLC. Okay, so one thing I wanted to mention here, the parameter of lid, when the lid has been placed, this lid parameter is written on the can. So this is where we are writing the parameter lid, which I showed you lastly. Rest is just the motion control, how it comes down, how it rotates based on the PLC signal. This is all defined in the editor. Let's come out. And similarly, we have the same thing happening in these jaws. So these jaws are reacting based on the PLC input. And basically, they're also giving you a feedback. This is the signal which is coming back from the jaws. When it is being grabbed, we get the signal in the PLC, and then we execute the next step. So I was coming back to this label printer. And if you open this object, and if you see this editor, we have the same way how this has been defined. This is in the behavior. There you go. So here I'm also, you can see that here, if the label is goulash or if it's bean soup, okay? And based on that, we are writing this data. Finally, this is being written here. So the data, RFID data, which is written on the component, this is happening in my component. RFID read-write is not happening in PLC. Okay, we are doing that internally in our components. Although you can do it using PLC as well, because we do have an RFID read-write component. So right now, RFID read-write is embedded in these units, which are writing the data. But if you see, I also have actually a video on that. I can show you a component, which is called RFID. You can go to public, read write with driver and read write. So if you see this is the component, looks much similar to IFM RF read write. And this component you can use, and then you can control this RFID component from PLC signals to read write the data on the component. So right now it's not happening with the PLC. PLC is just telling you to close and open, but you can use a separate RFID component to read write the data as well. All right, so this was the whole process. Actually not that complicated. It's actually very simple. You just need to be careful about how you're executing the steps, right? And if you have some questions regarding this steps, regarding how I'm doing it, feel free to write. I will check my comments. But now I'm going to show you shortly about the PLC program, how the PLC has been programmed, and how PLC is communicating with Simumatik. All right. So if I show you the PLC first, we have a PLC here. So if I open this panel, you will see we have a rack PLC. All right. This is a generic rack PLC. What does generic rack PLC means? This PLC can communicate to many other brands of PLC using different communication driver. You can connect that to Siemens. You can connect that to Allen Bradley. You can connect that to Vago. You can connect any PLC that you name, Delta, Schneider, Umron, because it supports various protocols like Modbus TCP, OPC UA, S7, and Omron Fins driver, Micro 800 simulator driver. You can also connect this PLC with a simulated PLCs like I'm using right now, OPC UA, and I'm connecting that to CODESYS. So I'm not having a real PLC right now. I'm just connecting that to a CODESYS, but you can also connect that to a real PLC. So there are different possibilities to connect this PLC. Now, why do we have PLC here? Because we have several sensors in our system. We have this entry sensor, the sensor to align the object. In here we have sensor on the jaws. Here we have also sensor on the jaws, and we have sensor on the component as well. And sensor in the end, we need a feedback. Okay, so this sensor is giving signals to this PLC. And we can see that the signals are changing. This is the inputs, all right? And these signals, when it comes to this PLC talks to my CODESYS. So let me show you that here. So if I go to my control, you will find all the control elements here. Let's open that. And there you will see PLC logic module. And this is the PLC logic module. And here I'm using OPC UA client because my CODESYS is OPC UA server. And I'm using Simumatik PLC as an OPC UA client. So the client has some parameters. This is the IP address, localhost, and this is the port address for OPC UA. All right. This is just the feedback that variables were found, everything is working good. Status is running. And now this is just the PLC. This is just this part. This module is the PLC. Now we have input card. This is an extra digital input card, which is over here. If you see over here, this is my digital input card. And this input card has a variable, which is called inputs 01. Okay. This variable you can find in my CODESYS, inputs 01. So whatever input this input card is reading, it is being sent to this input 01. Right now you can see that the value is 6. So this is like a decimal value coded from this Boolean signals. Okay. Similarly, you have another card. So I have digital output cards, 2 digital output and 1 digital input. So this D0 means digital output, right? Because I have more outputs than inputs. So similarly, we have digital output card, which has some specific address, which is output 01. And this is what we have mentioned here. Okay, this is also having some values coming from the PLC. So what happens? Inputs from this PLC via OPC UA goes to my CODESYS. And in my CODESYS, I have a function like a read inputs. So basically, this is a function which is reading the inputs of my global variable and passing that to my local variable. So from there, you can see that this GVL input 01, I'm taking individual bits and I'm passing that to my PLC program, which has some tags, so some variables. Okay. And then in the PLC program, you can see here, in the PLC program, I am calling these function blocks and I'm passing these variables, which were my inputs, to these function blocks. So these function blocks also have variables. So first I'm reading the global variables to my PLC local variables, and these local variables are passing the sensor data to the function block. And this function block will execute based on these signals, which are sent by this input. And then it generates some outputs. So function block gives me some outputs, which is over here. And these outputs are given back to my PLC variables in the PLC program. And then we have another function, which is called write function, write outputs. This is writing the data from my PLC program back to global variables. And these global variables, output 0, 1, is then further linked to this output card over here. And this will generate voltage in the end. So digital output card, here you can see that. This is the output card. And here you can see that the voltage is being generated. And then these voltages are triggering these units, these mechatronic units, okay? So all the control is happening in the PLC. This system is just sending the signal to OPC-UA. OPC-UA is solving the logic, sorry, CODESYS. Via OPC-UA, CODESYS, we solve the logic, send the signal back to SIMUMATIK to execute it. That's the whole process, how SIMUMATIK is linked with CODESYS. And this is just one example. All right. And this is how PLC has been programmed. And one more thing, I have some points that I want to talk about. All right, what are the next steps? So right now you can see that you have just one CAN coming, okay? Because this is not the optimized process. You need to have production keep going on. So what is just a basic overview of one cycle, how the whole cycle is being completed. In the next webinar, I'm going to show you how multiple CANs are coming. Okay, then we will make a buffer of CANs here. We will put some cylinders to stop the CAN from going forward. And then we remove the cylinder once the next unit is free. So we will read the status if the unit is busy or free, and based on that, we will push the CANs inside to make production a little bit faster. Right now, you can see the production data, I think in CODESYS, I made some variables, which I can show you. This is in PLC program. And if you go here, I have mentioned process CANs. You can see it's 23. 23 CANs are processed. And we have final output somewhere. This is the steps. There you see, total CANs is 22. Process was 23. Total is now 23, out of which 11 were goulash CAN, 12 were bean CANs. So we were counting the CANs based on what is the content inside. So right now, process CAN is 24, total is 23 because one CAN is being processed. So you can see that only one CAN on the process line. So we are counting actually the CANs from this last sensor. This sensor is telling us whether it's a bean CAN or goulash CAN because this is kind of like an RFID reader. It's reading from the RFID data written in the CAN. So this is going to tell us the total CAN, and the front camera, or not camera, front sensor is telling you the process CAN, okay? So that's how we are getting the data out of this system. Besides that, we are also getting the data of this tank, the level of the tank. You can see that now the level is quite in the center, right? And this you can also reduce from here. If you press on the red button, the level will reduce. If you press the green button, it will increase. So you can manually adjust the level as well. Okay, and if the level is 0, it will not fill the CAN, and you can see that it will not execute. So let me just empty all the level. There you go. So it goes down. Now tanks are empty, so nothing is being filled. Okay, so it's not generating any alarm. This you can also program. If the CAN is not, the level is not changing in the CAN, you generate an alarm because the level is not being filled. So I can now fill the CANs. You can see that it will start filling. So let's fill both of these. Now you can see that it execute and start filling. All right. So these data of the CAN, you can also of the tank, not the CAN, you can also read in GVL. And here you can see that goulash level and the bean level. This is the level of these tanks. So if I have to show you my split screen, I can reduce the level. So let's reduce this one. Now you can see that bean level is 0. Okay, so you can play around with the level of these tanks. And this is for goulash level. Okay, you can have more tanks. If you want to fill different liquids, you can have more tanks to fill it in the CAN. So this is the current step. What is the next step? Next step is I want to make this production more faster, which means I would like to have multiple CANs here, which I'm going to do in the next live webinar, possibly next month. And the step after that will be to create a dashboard to monitor the data. All right, just to monitor the data, to monitor how many CANs has been produced, how many of them are goulash CANs, how many of them are bean CANs, what is the status of these tanks, and what is the status of number of seals that can be filled, status of these this level of labels, how much label is left. These kind of information I want to read on the dashboard. So perhaps I will use Node-RED or FlowFuse to show the data from this system. And there are two ways to read the data. One is if you want to read the data directly from Simumatik, you can also do that, but it's a bit complicated. The next next way is you can read the data directly from CODESYS. Because we are getting the data in CODESYS, I can read directly from CODESYS. I can make a small dashboard and I can show you how this data can be read. All right. And after that will be the most interesting part. After that, what I'm going to do is I'm going to collect these cans. And then I will put these cans in a tray where I can put maybe 6 or 9 cans. So I will use a robotic arm. I'm going to use URSIM, Universal Robot. So I'm going to program this robot, and I'm going to show you how you can pick the cans, put it in a tray, and then I'm going to use an AGV, which will take this tray from one position to another. That will be the end of this whole webinar series. So once the production is done, we're going to store it in different, I don't know, I will see which kind of plate I need where I can make some sections and store the cans. And then I'm going to move this tray from one location to another using an AGV, just to show you the possibility that you can have in Simumatik, which allows you to learn and practice and have fun at the same time. So right now you can see that the can is just being exit from this red cone or pink cone. And later on, we will extend this process. So it will be a little bit complicated. So that's why I said, if you're the first one watching this webinar, if this is the first webinar you're watching from Code and Compile, you can watch the old webinars in our course, PLC exercise using CODESYS and SIMUMATIK. For free, you can join in Code and Compile website. All right. Then you can continue with the next webinar. All right. Now coming back, if you have any questions, let's check it out, the chat. So with 3S asked, I need a course only for WinCC, can make and upload it. I don't have a WinCC course with me. Also, my time is very limited. I have several projects to work on. So unfortunately, I can't recommend you where you can learn, but I believe on Udemy, you can find many courses on WinCC, SCADA, if I believe you are asking about SCADA, right? You can find many instructors on WinCC SCADA, or just put a post on LinkedIn. There are many people who can advise you where you can learn that. All right, next question. Need a course on SEW movie drive inverter and configuration with SM1500. I don't have a course on SEW drive. It's a very specific course. I would say you can contact SEW drive. Maybe they have some tutorials or some documents that you can read to understand how the SEW drive works. And interfacing with Siemens PLC should not be that difficult if it supports Profinet or OPCUA, I believe Profinet, that you can use, or ProfiDrive. Then you can easily connect with Siemens PLC. Again, reach out these drive guys and they can help you. In my Code and Compile website, you will find a course on Delta server drives and VFDs from Ellen Bradley and Delta. These are the drives that are available, but not for SEW drives. Anand wrote, explain from the process, taking an example. I just explained the process, Anand. You can see the live example here. The process is very simple. Empty cans are coming. They are being filled alternatively. One time goulash is being filled, one time bean curry is being filled, and then we are putting a lid on the top. That's the second step. And once the lid is there, then it moves further. And then it tries to put the label on that based on what was filled before. Okay, this is what the process is going on. Anand is asking communication between CODESYS and PLC. So CODESYS here is talking to Simumatik via OPCUA, or Simumatik talking to CODESYS via OPCUA. So you know that whenever you are working on CODESYS, you have an option to add a symbol configurator, which you can see that over here. This allows you to build an OPCUA connection with the server. So here you can see that in symbol configurator, I have this GVL, this is my data block, which has all these variables, like word variables, which are being selected. And these variable addresses I put in Simumatik. So for example, again, I show you digital input card. I have this variable input01, and that is coming from here, input01. So whatever value input01 has in Simumatik goes to CODESYS via OPCUA. If you want, you can also monitor the data via any other OPCUA client. You can use UA Expert, and then you can connect to CODESYS as well to read this data. Or you can also write the data. And similarly, all these variables are defined in global variables. And one more example, I can show you this analog input, how this analog input is done. So if you see, I also have in my control analog input card. And if you want to see this card, this is actually in my PLC panel. I can open this panel, and the last card, sorry, this is 8 analog input cards. So this card is also there, and this card is connected to the analog inputs of the system. So here you can see that if I go down, I have connections, and there you can see the analog values being popping up. So do you have, this is connected to, if I hover on to this variable, it's connected to soup dispenser left level signal. So this is connected to this tank, which is on the left one, this one. This is connected to analog input 0. And this is basically your bean soup level. Let me just verify one more time. Oh, sorry, this is a goulash level. So analog input 0 is goulash level, which I have mentioned here and here as well. And the next one is bean level, analog input 1. Analog input 2 is the lid count, the number of lids, which is mentioned here. And then you have label goulash and label bean. So all these variables which you see here, the tank level, the level or the number of lids that are left, or the labels, which is going to be empty, I can fill it. Labels which are left, these are analog input values, which are going to the analog output. We don't have analog outputs in this PLC. Maybe in the next units when I'm going to connect, maybe I need it. But right now, we are just working with digital inputs, outputs, and analog inputs. Another question comes from retrieval. If I want more experience in TIA Portal, how to make practice and where in which platform? So TIA Portal, you can download from Siemens website. You have 21 days trial version that you can use. If you want to have a license, you can contact them for the license. And if you want to learn TIA Portal, I have a course on TIA Portal. So if you go to codeandcompile.com, this is the name of the website. You can go to the courses, and here you will find several courses, many of the free courses, but free courses has a limited information. You can go to all courses and just type here, Siemens. And then you will find courses related to Siemens. I have Siemens S7-1200 Basic, Advanced, and I have S7-1200 with Ignition SCADA, S7-200. So these are the 4 Siemens courses that I have. You are talking about, I think, S7, yeah, TIA Portal. So I'm using TIA Portal for these S7-1200 PLCs. You can learn Siemens PLC from there. And you can also, instead of CODESYS, you can code this whole program and connect to TIA Portal instead of CODESYS. All you have to do is you can either use the same driver, OPC-UA, or you can connect a different driver, which I can show you in the control. We have PLC logic module, and if I open this drop down, you will see we have driver PLC Sim, so you can connect directly to PLC Sim. You can also connect directly to PLC Sim Advanced if you have, or you can connect via S7 protocol. This is for the Siemens. And these are all the available protocols. You can have a look. Many of the protocols are also for robots, but we use it for robot controller. But here we can see different protocol, S7, PLC Sim, or you can also connect that to Beckhoff using TwinCut ADS driver. And we also have a driver for Allen Bradley. We have a driver for Micro 800 PLC simulator. So you can also connect directly to the simulator. And we have Modbus TCP client as well. So most of the PLC has Modbus server inside, so you can connect to virtually any PLC, if this answers your question. So Anand, got it, thanks. All right, great. I still see 19 people are logged in and watching me and hearing me. Feel free to ask your questions that you have. And if you have some expectations for the next webinar, feel free to write that as well. What would you like to see? Expectations related to what we can do more on this process. Right now, we are just filling the bean or the soup. We are putting a lid, putting a label. What would you like to see next? My idea was I'm going to collect these cans in a tray. I don't know what's the correct word, tray where these cans are stable. And this is going to be happening by a pick and place robot. I'm going to use UR5 or UR3 would be also fine. And I'm going to program this robot using Polyscope, which is a robotic programming software from Universal Sim. So I'm going to run this robotic software on a Docker container. So there is a Docker container now available. You can just run the Docker container and you can program the robot. So we're going to put the robot here in the Simumatik, control it using robotic software, interface that with Simumatik and pick the cans. It will be very interesting. Put it in a tray. This will be the one live webinar. One live webinar will be about getting the data out using Node-RED. Node-RED is what I prefer because it's open source, it's a free tool, and you can also learn about how Node-RED can be used. And third live webinar will be on AGVs. Then when everything is ready, how AGV can deliver the tray from one location to another. You can also program this AGV. I will see which programming platform will be good for that. All right, another question. With Revel, you said, even we learn courses, we need practice, then only I can able to. You can practice with Simumatik. This is the platform. So right now you see this is just one system, right? I can show you more systems. So here, okay, I have to stop the emulation. If I click on load, and if I go to public, you can see there are many systems. So let me just click on manage system, and then you can see much better idea about it. So we have systems starting from scratch. For example, this is a pallet lift table. This is just the filling example. This is just the one conveyor with motor and PLC. This is electro-pneumatic system, motor control. This is simple conveyor control. This is the system that I'm working on right now. And if you go down, let's see, I can show you this. These are the private. Let's go to public. So public system is what you can access right away. So we have IoT room, we have a line following robot. This is automated handling and palletizing with a big robot. We have done a webinar on that as well. It's a board charging station, coffee machine. These are actually very basic system, but you can also create your own system based on what you want. Then we have demo pick and place gantry, and we have some monitoring stations, sorting stations, and yeah, countless systems we have starting from conveyors and pick and place, some tank level system, PLC challenge factory. This is 2 factory cells are creating some products, and we can assemble that. Some SMC systems we have. This is the PID seesaw ball and some trading station. All these systems, if you will sign up to Simumatik today for free, you can access these systems. Like I said, there is a free account in Simumatik where you can just access the system, connect to PLC Sim, connect to CODESYS, and you can program the system. But if you want to change something, you can't do that. If you want to create something, you can't do that. You can't even save the progress of your system. That's the limitation, and I'm going to talk about this limitation shortly. But you can access the system right away. So here is Robot DK, simple sorting, and most of the system has a PLC program inside it, in the asset. So you can download the PLC program as well. So you can see there are a lot of systems that you can work on right away. And yeah, if you want to learn more about Simumatik, you can go to academy.simumatik.com, and we have several courses there. I created all these courses from scratch, and you can learn more about the system. Any other question? Okay, Nirmal Jusair has a question. How can you optimize your computer to have smooth Simumatik animation like your webinar? So good question. So for sure, it's a 3D software which is running on a 3D engine. A lot of physics are going on. So if you don't have a graphic card in your computer, so right now I'm using a graphic card. I have 3070 RTX, but if you don't have, there is an option here. You can go to settings, and you can go to graphic and reduce the scaling to 50% and reduce the rendering to, let's say, 100 meters. And now you can see graphic is not so smooth, but your simulation will be smooth. You can move quite easily. You can reduce the graphic, and you can also you can even reduce it more. So if I reduce the rendering distance to 10 meter, you will see that it will only render until 10 meter. It will not render further. This will also reduce some graphic power. This is how you can do that. So Nirmal asked me, hi Rajvir, great to see you. I want to know, how can we monitor one SCADA from another through cloud or any other platform? I will get back to you about this question later on after this webinar. So if you have a question related to webinar, please ask me. With Revel, I hope I answered your question. So now I'm going to talk a little bit about the license. Like I told you, there is a free license and there is a paid license. Okay. So with the free license, there are some limitations. Like I told you, you cannot save your progress. You cannot create components. You cannot create systems, but you can just use the existing system. If you want to buy the license, there are some options. One is monthly subscription. If you want to just test out how Simumatik works, it's 25 euros monthly. You can calculate in your own currency if you're in a different country. If you want to buy 6 months access, it's 99 euros, one-time payment, where you will get all the features, plus you will get a premium support. So I'll be there to help you out when you're building something. If you want a 12-month access, it will reduce to 249 euros. You just pay one time for 12 months, you have the access, and you will get some credits. Now, what are these credits? You can go to Simumatik manual and you can learn more about the credits, but in short, I can tell you can use this credit to optimize your 3D CAD data, and you can convert the CAD data from one format to another. For example, you have CAD files in SolidWorks or, I don't know, object mode or step file. but in Simumatik we use GLB files. So we prefer you to upload GLB files, but you don't know how to convert. Then you can use these credits to convert that file. I can maybe show you shortly. It doesn't take much time. So for example, I have, let's talk about this component. This component, I have it here. And if I open this component, if I go to the asset, you can see this is already a GLB file. If this is not a GLB file, I will get a button here to convert. And then to convert it, I need to use credits. And after that, you can also optimize it. Optimize means when you import your CAD data, it could have a lot of triangles. And this needs a lot of physics engine to process those triangles. So to avoid these triangles, you can reduce the number of triangles. This will change a little bit how it looks like, but it will increase your performance. And this you can do by optimize. In the optimize, you can select how you want to optimize. You want to have a performance-based optimization, balance, or quality. You can select the mode, and it will take credits, I think 2 credits per optimization. So that's where the credits are being used. Another way is you can also run Simumatik on the cloud completely. And there you have to use your credits. So I think 1 credit is 1 hour. I'm not 100% sure, but that's where you can also use. So in case if you don't have a high-end system, you can use a system on the cloud, and there you need the credits. So this is the difference in different plans of the paid plans. But another plan is we have a special offer from Code and Compile. If you join via Code and Compile, you get a special offer, 20% off, by using a coupon CAC20F. CAC20 off, basically 20% off, right? So this will reduce your license price from 25 euros to 20 euros per month if you subscribe monthly. And if you subscribe one time, 6 months license, 119 euros, 12 months, 199 euros. This is the recommended one. So you can practice for 6 months or for 12 months. In 6 months, what you can learn? You can learn PLC programming, you can learn IoT, you can learn hydraulics, you can learn pneumatics if you're a student, if you just want to learn. And you can also learn how to build system. You will learn more about digital twin. You will learn Python as well, because all the systems are modeled using Python scripts. And you can learn how to interface the system together. You will learn more about virtual commissioning. You will learn more about how to make digital twins, how to make a digital twin of your real system. So all these learnings you can do, and the learning material is on Simumatik Academy. Or you can also get courses from Code and Compile. If you're already having courses, you can just get Simumatik. All right, everything is in one package. If you have any other questions, feel free to let me know. Otherwise, this was all from my side. Thank you for your time and for your patience. I think we covered 54 minutes today. And I'm more than happy to answer your questions. Feel free to pop me questions later on as well if you don't have right now. Otherwise, thank you for joining. Thank you for your time. And I wish you a great upcoming weekend. Stay tuned for the next webinar. Have fun. Bye-bye.